Example, use the midpoint rule to approximate the integral from -1 to 3 of 4 minus x squared dx on the closed interval from -1 to 3 using n equals 5 subintervals. We'll begin this problem by computing the width of one rectangle. That would be the delta x, which is equal to b minus a divided by n. This would be 3 minus -1 divided by 5. 3 minus -1, 4, so we'll have 4/5. Let's draw our interval. We'll start with the left end point, and we'll call that x sub naught equals -1, and mark the right end point, which will be x sub 5, which is equal to 3. Now, we're going to have 5 subintervals. We'll mark those along our interval line, and each width is 4/5. So starting at -1, -1 plus 4/5 will give us x sub 1 equals -1/5. Add another 4/5 to that, x sub 2 equals positive 3/5. Add 4/5 to that, x sub 3 equals 7/5. Add 4/5 to that, and we'll get x sub 4, these are our grid points, equals 11/5. And for continuity, make sure you check 11/5 plus 4/5 is 15/5, which takes us to the 3. We need to compute the sample points, and the sample points are the midpoint of each interval. So we'll begin with x sub 1 asterisk. That's the point between x sub naught and x sub 1, between -1 and -1/5. That value is -3/5. We need to find the midpoint between the grid point of x sub 1 and x sub 2 to get us the x sub 2 asterisk, our sample point, which is the midpoint, and that is 1/5. We'll continue. We need the midpoint between x sub 2 and x sub 3. That would be the sample point we call x sub 3 asterisk, right smack in the middle of those 2 points. That's 1. Continue. Between x sub 3 and x sub 4. The sample point we would mark as x sub 4 asterisk, and that midpoint is 9/5. And finally, the last sample point between x sub 4 and x sub 5, that would be x sub 5 asterisk. The midpoint there is 13/5. The integral is approximated by delta x times the quantity f evaluated at x sub 1 asterisk plus f evaluated at x sub 2 asterisk plus the function evaluated at x sub 3 asterisk plus the function evaluated at x sub 4 asterisk plus the function evaluated at x sub 5 asterisk. Let's put in our values. Delta x times, and for the x sub 1 asterisk, we'll put in -3/5. For x sub 2 asterisk, we replace that with 1/5. For x sub 3 asterisk, replace it with 1. For the next sample point, we computed that as 9/5, and the 5th sample point, 11/5. Use your calculator and approximate each function value to 2 decimal places. 4/5 for the delta x times 3.64 plus 3.96 plus 3 plus 0.76 minus 2.76. That's approximately 6.88. We earlier computed the exact value of this integral as 20/3, and decimal form it's 6.6 repeating. The midpoint rule with 5 rectangles is a pretty good approximation.